This is Hierarchy Education, and today we will be solving linear equations with a variable on both sides. The following is an overview on how we will be exploring today's topic. Before we begin, let's point out our two goals for solving these types of linear equations. The first is to combine like terms, and the second is to isolate our x variable, like we do when we're solving linear equations with just one variable. Let's look at our first problem. We have 3x plus 2x plus 3 is equal to 4 plus 6x. Starting with our first step, if we recall, combining like terms, we can observe our 2x and 3x and note that they are like terms, which means that they can be added first. They can be combined first. So 3x plus 2x, well, that gives us 5 of these x's, right? 5 of this particular quantity. So we now have 5x plus 3 is equal to 4 plus 6x. We're going to observe whether or not there's any other terms that we can combine. And we're going to note that 5x and 3, well, these are different quantities, so they cannot be combined. And 4 and 6x, these are also different quantities, so they can't be combined. However, the 5x is the same quantity as this 6x. So we can move this 5x over using our subtraction property of equality in order to combine those terms. So let's go ahead and do that. Let's go ahead and subtract 5x on both sides. And that's going to give us 3 is equal to 4 plus x. And now we're going to note that 4 and 3 are similar quantities. So again, using the subtraction property of equality, we're going to subtract 4 on both sides, and we get -1 is equal to x. Now this right here is the answer. However, I don't really like our x's being written on the right-hand side, so I'm just going to rewrite this by flipping our terms and saying x is equal to -1. And I will present that as the solution. For our second problem, we will be looking at 10 times the quantity of z minus 1/5, which is equal to 3 times the quantity 3z plus 2. This is a really interesting problem for us because it's going to be bringing back the distributive property. And the distributive property will be used so much when solving problems where we have a number multiplied by some quantity. So to start, let's go ahead and take this 10, and I like to use these little arrows to indicate the distributive property that it's being multiplied to everything. And we get 10z, that's 10 times z, and then 10 times a -1/5 is -2, which is equal to, we'll go ahead and do the same distributive property on the right-hand side, 9z plus 6. And now, looking at our combining of the like terms, we can see that 10z and -2 are not the same quantity, and neither is 9z and 6. However, if I move things over, I can see that 9z and 10z can be combined if the 9z was on the left-hand side. So I'm going to move that over with, again, the subtraction property of equality, and we're going to subtract 9z on both sides. And that's going to leave me with z, 10z minus 9z is just a z, a single z, minus 2 is equal to 6. And then I'm going to use the addition property of equality by adding 2 on both sides to leave me with my final answer, z is equal to 8. For our last problem in this topic category, we are going to be looking at 6 times the quantity z plus 3, all divided by 2, which is equal to 4 times the quantity z minus 1. We're going to start with the multiplication property of equality. I like to set it up as the distributive property, however, where I put my entire equation in a parentheses or a bracket. And then I multiply by 2 on the outside and distribute this in because it helps me practice that 2 gets multiplied to every piece in the equation. That's going to leave me with 6 times z plus 3, which is equal to 8 times z minus 1. That's the 2, which cancels out with this 2 with the commutative property, and then 2 times 2, which is 8. And then we'll use the distributive property again on both sides of the equal signs, and that leaves me 6z plus 18 is equal to 8z minus 8. I can then subtract 6z on both sides, subtracting 6z, and I get 18 is equal to 2z minus 8. We can then add 8 to both sides, and I get, let's see, 26 is equal to 2z, divide by 2 with the division property of equality, and I get 13 is equal to z, or again for me, that will be z is equal to 13. And that is our solution. For our second topic, we will be discussing how we can get infinitely many or no solution from our linear equations with variables on both sides. Let's start with infinitely many. The problem that we will be looking at will be t minus 8 is equal to a negative 8 minus t. At first glance, the problems look different, but if we notice, we can do a distribution property here with this negative. This is, in fact, a negative 1 out front. We'll distribute in the negative 1, and we'll get t minus 8 is equal to a negative 8 plus t. Let's go ahead and reorder this. We can restructure the way that this negative 8 plus t looks. So it looks exactly like the left-hand side. So we'll have t minus 8 is equal to our positive t first minus 8. And we notice that we have the exact same thing on the left side and the exact same thing on the right side. We can actually stop here and say that this equation is always true. If we take it further, if we take it through all of our steps by using our properties of equality, we can add 8 on both sides, and that gives me t is equal to t, which should be a true statement. It's like 1 equals 1. And we can even subtract t from both sides to give us 0 is equal to 0. Most students, when they get here, they view this as being an incorrect answer because that doesn't make sense to them. But we really want to look at it as the truth value of the statement. Right now, we are saying that 0 is equal to 0. And I want you to ask, is that true? Is it always true? Your answer to that question should be yes. There is nothing that will ever make this statement not true. And because it is always true in every single case, this particular equation has infinitely many solutions. No matter what you make t, we will always have a right answer. And you can see that even from any part of these equations by letting t take on any value. So for instance, I'll say t is equal to 3, and let's go ahead and plug in 3 just into this part right here. So I get 3 minus 8 is equal to 3 minus 8, or negative 5 is equal to negative 5. And you can do this with any number, and you will always get a true statement. Moving on to no solution. Let's go ahead and look at the problem. 4x minus 2 is equal to 2 times 2x plus 1. We can start this problem by distributing on the right-hand side. And that's going to give us 4x minus 2 is equal to 4x plus 2. One thing of note is we could actually stop right here, significantly because we can see that this is taking some number 4x on both sides. And on the left-hand side, we are subtracting 2. And on the right-hand side, we're adding 2 to that same number. So we know that this can never be correct. However, if we take it all the way like we did on the infinitely many solutions, and we go ahead and use our properties of equality, I'm going to add 2 to both sides to leave me with 4x is equal to 4x plus 4. And then I'm going to subtract 4x on both sides to get all our x's together, and that gives me 0 is equal to 4. And much like our interpretation of the infinitely many solutions, we've taken it all the way to the last step, and look what kind of statement we have. We have a false statement here. 0 equals 4. This is not true. This will never be true. It can't be true. And thus, this entire problem, since once we take it all the way to the end, we have a false statement that is always not true. This right here has to be no solution. Has to be no solution for us. There is no number for x that could ever make this true. Moving on to our try it problems. On the next page, go ahead and pause the video when you see the problems appear and give a shot at all of those problems on your own. It's going to be up to you to determine whether there is a single solution and what that solution is, whether there's infinitely many solutions, or whether or not there is no solution to the problem. Here is the solution to the first problem. I think the only tricky part that someone might run into is that we're working with 35 and 28. So when it comes to the addition of these numbers, if you add incorrectly, you may not end up with the correct solution. The solution to the second problem, important to note that at the second line, as soon as we get 6y minus 8 is equal to 6y minus 8, we could stop there if we saw that this was the same thing on the left side is equal to the same thing on the right side. That already tells us it's infinitely many solutions. But taking it just all the way to the end, we end up with 0 equals 0, which is a true statement always, so we know from there that it is infinitely many solutions. For our third solution, we actually could stop at the second line again as well. As you can see, we end up with 25t plus 5 is equal to 25t minus 7. And if you can see that those, no matter what you do for t, are going to be different numbers on both sides, then you can see that there's going to be no solution. But if we take it all the way to the end, using our properties of equality, we end up with 0 equals negative 13, which is always a false statement, which means that we have no solution here. And for our last solution, certainly the one that is the most involved, we can see that we actually start out with a distributive or a multiplication property of equality. I like to set it up as a distributive property by taking the 4 and putting our entire equation in our parentheses and distributing in the 4 against each piece. The hardest part for a lot of students is remembering that this 4 gets multiplied by every single piece. Most students, or many students, will forget that it multiplies by this 2 as well. And just make sure as long as you are multiplying by every piece, you are doing it correctly. That will leave us with the 12y is equal to 8 minus 12y plus 8. Going through our properties of equalities, we end up with this ending step of 24y equals 16, where we then have to divide by 24. I have so many students who don't like working with fractions. I threw this one in on purpose because there are just as many fractions as there are whole numbers in the world. So it's important to note that we are just as likely to end up with fractions as our answers, and we should end up with 2/3 here, because we get 16 divided by 24, which can be, top and bottom can be divided by 8, which would leave us with 2/3 for our solution. And our last topic for the video is going to be error analysis. Just as a little bit of a refresher, this is where I solve a problem in front of you, and you see if you can spot the error that I am making. For our first error analysis, I have 4x is equal to 6x. Because the left side and the right side are not equal to each other, I can immediately stop right here and I can say that this problem has no solution. I ask you, what is wrong with my analysis here? For those of you who mentioned that, well, we could do the subtraction property of equality, you would be absolutely correct. We can actually subtract on both sides here, and we would end up with 0 is equal to 2x. A lot of students like to interpret here is no solution as well. However, again, no solution is incorrect. I can divide both sides by 2, and I get 0, because 0 divided by any number is 0, is equal to x. And x is more than capable of equaling 0. Our answer is actually a solution, and it is x equals 0. And for our last error analysis, I have x minus 4 is equal to negative times 4 minus x. We're going to start by using the distributive property, and I get x minus 4 is equal to a negative 4 minus x. I'm then going to add 4 to both sides, and I get x is equal to negative x. I'm then going to add x to both sides, and I get 2x is equal to 0. Divide by 2 on both sides, and I get x is equal to 0. That is my solution. Where did I go wrong? For those of you who answered that I distributed incorrectly, you would be correct. To look at the actual solution here, we have x minus 4 is equal to a negative 4 minus x. If we distribute correctly, we get x minus 4 is equal to a negative 4 plus x. If I rewrite the problem, I get x minus 4 is equal to x minus 4. That's just me writing this x on the left side and this negative 4 on the right side. We can see that these are the same thing, and I in fact have infinitely many solutions because it's the same thing on the left side is equal to the same thing on the right side. If I take that all the way, I will end up with something that looks like 0 equals 0 right at the end. Now I want you to note that in our previous example, when I solved it right here, if I got x equals 0, if I were to check this solution by plugging this in, it would come up as a true statement. So that might be a little bit deceitful and tricking you into thinking that this is the only answer when in fact there are infinitely many solutions to the problem.